Hello. In this video, we are going to explore and demonstrate one vulnerability type called a zero-click account takeover, which essentially means that an attacker can fully compromise an account without having to send something to their victim, like a malicious link or something like that. They can basically just complete the exploit chain themselves from start to finish. And to demonstrate this, we have created this intentionally vulnerable lab called netbanking. And for this demonstration, we have chosen to implement a login system that uses a one-time password. But this is also commonly found, these vulnerabilities, in like password reset functions. But essentially, if the only thing that you need is an email from the system to authenticate or reset your password, then this attack might work if the conditions are in place or the vulnerability is in place. So just to kick things off, let's just explore how the authentication works here. So we have this sign-in form where you can input your email, and if you don't have an account, you can create a new account. So we have a Gmail inbox here for a user named nbnormaluser@gmail. So let's see if he has an account. And he does. So he's attempting to sign in. And then what the system does, instead of prompting him for a password, the one-time password gets emailed to that user. So you can see it's from netbanking and it was sent to our user right here. And here is the login code. So if I grab that login code, press sign in, we can see that the user is now signed in. So that is essentially how this authentication is implemented for the system. But let's look at this from an attacker's perspective, and let's look at a little bit how some databases actually implement lookups. There is this feature in databases called Unicode collation, where essentially it helps the system to find the information that you're looking for. And to give you a good example, you might have a question that says, do we have a user in our system named Jose? So if someone types in Jose, like that, the system may not return anything because the entry in the system was Jose. But if you have Unicode collation enabled in your database, then this Jose will return or match this Jose. And basically, in other words, when you have characters like au, yeah, e, etc., they are equivalent, and the database will return those results that are equivalent to a, e, I, like that. So they're treated as the same value, even though they're stored differently when doing the lookup in the database. So knowing this, what an attacker could do, they could target a domain and try to see if the database lookup actually has this Unicode collision enabled by registering something called a Punycode domain. And that is what we have done for this lab. So here, if you look at down here, this is a Punycode domain that we have purchased. And this doesn't look anything like gmail.com, but that was the purpose of seeing if we can trick the system to give us a code for a gmail.com domain if we would provide it with a gmail.com domain address. So this domain right here that we registered, if we convert it to a just human readable form, we can see that it translates to this version right here of gmail.com, like so. So, okay, so we as an attacker, we have control of this domain, and we want to see if the database lookups actually matches this Gmail with this Gmail right here, like so. So what we have done is we have created registered the domain. We have created a redirect email, which basically says all email addresses that are sent to our domain will be sent to a gmail.com inbox that we have registered right here. So let's proceed to the attack and see, can we do a zero-click account takeover of this user, John Doe? So I will just hit refresh right here. And to showcase if we can log in normally using our new domain, I'm gonna use the nb normal user for John. And I'm gonna swap out and use our version of gmail.com, our attacker domain. So if I press send code, no email was sent. And this happens because, well, first of all, there is no user like this in the database system. It also happens because behind the scenes, the browser will actually change this version of gmail.com, and it will actually send it like this. So it will be db normal user at this. So this is how it would actually be sent to the server. And that's why it completely breaks. So what we have to do is we have to intercept this message. We can use a proxy tool like Burp Suite or OWASP SAP or something different. And I have set up here Burp Suite. So before I ask for the code, I'm going to intercept this message. And I'm going to press send code. And right here, I have the entry that I just typed in. So you can see db normal user at gmail.com. That's right here. So I'm going to change this. And I'm going to say, okay, I'm going to use this version of gmail.com, the domain that we own and control. And I'm going to forward that and turn off the intercept. And the system now says login code sent to nb normal user at this other domain. So the system is saying it's clearly a different account. But in reality, when we look at the email that we received, we can see right here that the email was received to rb normal user at this custom domain that we have. And if I take that code right here and log in, and by the way, this email inbox right here is the attacker controlled email. So everything here, this one right here is the normal user, and this is the attacker's inbox. So I enter the code, and now all of a sudden I can log in as John Doe. And you can even see here that the email address that is currently logged in is this email address with a normal Gmail, even though we just received the login code to our attacker-controlled Gmail version. So this is a quick example on how you can exploit this vulnerability to do account takeover. But if I were an adversary and I want to create the most impact against the organization that I'm targeting, maybe I wouldn't go after a standard user. I might be interested to try to do an account takeover of a staff member or an admin. So if you go back and look at the email inbox for the normal user right here, we can see that the code that was sent to him is sent from this email address right here. So it's netbanking@gmail.com. So I'm going to sign out and I'm going to log into that account just normally, no account takeover. And I'm going to switch over to another email inbox right here. And you can see this is just signed in. I'm just signed into that email account. So I ask for a code. That owner gets the login code. I will grab it, log in, and now you can see that admin has logged into his own account. Great. But we can just essentially do the same as we did before. So if I sign out and I say, okay, I want to go after netbanking@gmail.com, I'm going to see if the database will do those equivalent of our domain when it looks up and generates the one-time password code and see if we can get that email to us. So again, I will intercept, I will send the code, and we can see right here, the request has not been sent to the server. It's stopped here in my proxy tool, and I'm going to update it to our version of gmail.com. So at gmail.com. Forward this. and the system says login code sent to netbanking@gmail.com. And if we look at in our inbox, might have to hit refresh. There it is. We can see now, dear netbanking administrator, your secure login code is this one right here, and we can validate it that the email was sent to our attack-controlled email address right here. Even though, if you compare this attacker's inbox to this inbox, which is the actual email inbox for the admin, you can see the name is the same. It's the same account. So we will grab the code from the attacker's email inbox, log in, and now we have completed account takeover for the admin as well. This was just a quick demonstration of how we can perform this attack. And we have also a blog that details this attack in more details and some remediation steps. And full credit goes to the researcher who reported this for the first time to Defend Iceland, named Lil Endian, which is also referenced in the blog post attached. So thank you so much for watching.